Hello everyone, this video is about the Physics Lab 1 for Physics 2211 about constant velocity. My name is Jacob Buell. So, as a little introduction to this lab, the aim of the lab experiment would be to implement Newton's fundamental laws of motion in practical scenarios. Specifically, the emphasis will be on Newton's second law, and the objective is to validate its precision. So this will be achieved by contrasting position versus time graphs generated from real-world data that we've taken from a video with those derived from a simulation model created in GlowScript. So, as a background knowledge, we need to know Newton's second law of motion. Now, Newton's second law of motion states that the net force is the change in momentum over time. Now, this law can be written as the equation shown in front of you. So F net equals ma, also the change in momentum over change in time. So this law gives us a couple bit of information. So it tells us that if the net force is 0, then the change in velocity is also 0. Therefore, the velocity is constant. So for this lab, we have the system and the surroundings. So the system is what the forces are acting upon, and the surroundings are everything else. So in this lab, my system is a ping pong ball, and the surroundings are just the outside world. For example, the wilderness in that bear. So for the outline of this lab, I recorded the motion of a ping pong ball rolling across a flat surface. Okay. I used the tracker software to track the position of the ball at constant time intervals, using a frame rate of 30 frames per second. Okay, and then you created a computational model of the theoretical position versus time using GlowScript code. And it was important in this code that the time step was also 30 time steps per second. So it lines up with the tracker software. So the next step would be to compare the data from the simulated model and the tracked real-world data and see if we can compare and get the constant velocity. So first, in this data of the tracked software, we got an initial velocity of negative 0.35 meters per second. So this is the code for the theoretical simulated values. You see it started at initial velocity of negative 0.35, and it was constant, with the time step of 1 over 30 for the frame rate. This is the graph for the tracker values versus the simulated values. So you can see the simulated values started off very close to the tracker values with a constant decrease down. And what is important about this lab, or how I did the lab, is that the ping pong ball is rolling in the negative x direction. So that is why the incline is going down to the right. So we can see for the tracker values in red that it starts to lose a little bit of distance, or the distance is kind of deviating from the simulated values, especially when we get to the very end, it starts dropping off. So in conclusion, the data shown is for the most part linear for the tracker values, which shows constant velocity. It deviates a little bit from the expected data, probably because of friction or an error in when the tracker began tracking the ball. Now, what if the axes were flipped? Then, like I mentioned, the ping pong ball, instead of being seen as moving in the negative x direction, it would be seen as moving in the positive x direction. Now, for the forces applied to make the net force 0, it can be assumed that the net force, would not be 0 in the real world because of the force of friction slowing the velocity of the ball down. So it wouldn't really be possible to know how many pushes and pulls are added to give a net force of 0 in the case observed.